So whenever you are adding new test, please consider using them in the SwiftTesting. So you can take the advantage of improved syntax. Migrate the older test into the new framework is parameterization test. If you had something like duplicate test, a lot of tests with doing the same thing, consider them to moving them to parameterization. So the test will be easy to read and manage. Please note down, it's not a complete replacement for XCTest. Hold on, at least not yet. So it's you have to still use them for whatever the performance or the UI wants. Tests are parallel by default. So please keep in mind you need to use the serialized trait if you want to run them one by one. And one important thing which Apple says is do not mix XC assertions with the testing macros. Are the same, testing macros with XC assertions. It works actually, but it's not what it has to be. Hi everyone, thank you for joining in my talk today. Today is going to be amazing because we are going to test the testing framework and we'll see if it makes our life any better. I am Muralidharan Kathiresan. I work as a senior iOS developer at Bally's. I created a website called swiftpublish.com, completely on Swift, with my friend Shahrukh, where I share my thoughts and tutorial on iOS development. I'm originally from India. It's been 4 years since I moved to UK. I'm also part of the Swift Leads conference team in UK, which happens on every October. Yeah. In my free time, I also do mentorship on mobile engineering. If you want to connect with me on anything, my DMs are always open, please. Why am I here with this topic today? Long time, there have been a wait for easy Swift-based testing framework, right? Now, we got something new and interesting. We need to talk about it, then only we will know how is the framework doing, is it better, what are its pros and cons, everything. Code quality is always important for a stable product. No debate on this, right? There is one more reason which is not listed here. It's the only topic selected by the organizers from my 3 proposals. Yeah. So now you know who am I, why I'm standing here. Shall I understand something from you all? How many of you write unit test in your day-to-day coding? Oh, that's huge. Okay, how many of you write the UI one, XUI test? Okay, thank you. I have seen many hands raised, okay? So let's check our memory with unit testing. So we know this icon is for when one or more tests pass, right? This one is one or more tests failed, we get this red symbol. So any guesses with this grayed out cross icon? Anyone? What is this symbol stands for? Yes, exactly. When you skip the test or you expect a expected failure, you have this one. So yeah, this is for the skip to one. The previous one is for the expected failures. Yeah. So any guesses on this one? So this is a mixed income icon. So if you run one or more tests, okay, so all your tests passed, and if you had any skipped test or expected failures, you get the green one with minus. And the last one is the red. So this is also a mixed income icon. So it has, when you run a group of tests, if you have a skipped one and an expected failure, but also you have some normal test also failed. That's why it's red. In a high level, XCTest supports all Apple platforms with the unit test, integration test, and UI test. And it's based on Objective-C mostly. Whereas the new testing framework supports all Apple platforms plus Linux and Windows too. Ideally, one misunderstanding or even in our team we had this. If you have the Swift tools version 6.0 installed which comes default with the Xcode 16, you can use it. This has no minimum deployment constraints or something like that. If you have the latest version, if your hardware supports, so you can start using the testing framework. And it supports only unit test and integration test as of now. And it supports all modern Swift features like concurrency and macros. SwiftTesting supports physical devices, so no more simulator only. You can run all the tests on your iPhone, Apple Watch, even in Vision Pro. Parallel testing is enabled by default here. In XCTest, you need to manually enable them if you want. Here it's enabled by default. If you are working on a multi-platform app, for example, you can run your entire test parallelly on all devices at the same time. And of course, Swift testing is supported on Xcode Cloud too. If you want to write a new test in Swift testing, simply import the framework in a test target and add a function with the test keyword. That's it, you are done. No need of any classes, no inheritance from XCTest case. Once you add this, you can see the test case in the test navigator, which is as usual. Okay, what is this test keyword? This is a macro. You can pass a display name for the test if you want, and any traits. What is a trait, which we will see detail in upcoming slides. What is this expect keyword? This is another macro which is used for asserting the outputs. Like in XCTest, we have lot of XC assertions, right? XC assert equal, XC assert not nil, etc., etc. Here, it's simply only one macro which accepts any condition of Boolean type. Around, I think, some 40 APIs were there in the XC assertion. Here, it's completely reduced into one simple expect macro. You can add comments also to the expect macro if you want to denote during the time of failure. If you want to add group your test, actually, if you have one or more tests, if you want to group them, you can do by just placing them in a Swift type. The testing library refers to such a type as test suite. Once you add it, it looks like this in the test navigator, which is as usual. This type need not to be classes anymore, and they don't inherit from XCTest case. This may be a stat, or even you can use an actor directly. This is really great, right? You may ask now, hey Murli, you said just import the testing framework and create a simple function for the test. So can I have my test case in the main, if I have a view model, can I write my test case in the main app itself? No, completely no. Test targets are always separate from your main app or your library code, anything. Do not import the testing library in your main app, because the test functions won't be removed, I mean stripped out from the final binary if you are creating a build for production or release. Naming, the hardest problem of software engineering. So with the test macro, you can use the display parameter to define the name of your test in a nice way. Check here, this is the older way. If you don't use any display name, it will look whatever is your function name. But with the test macro, if you use the display name, it displays whatever is the display name you input it. If you want to compare from XCTest, or if you are planning to migrate some of your old tests to make it more effective or readable, the major difference is there are no more setup methods. You can use the init space for whatever you was doing with the setup before. Same with tear down methods. You can use the dinit. And Swift testing do not force you to use the word test before every function. that's how we were using in the XCTest, right? Here you can name the test function directly, like what are you trying to test here. So what are the improvements so far? Use of macros, we have just seen, and the Swifty syntax give more readability. You can easily understand what is your test doing or intended to do. So those two makes less boilerplate. And as you've seen before, test now supports global functions, stacks, and actors. Actionable failures. This is my favorite part. Let's check this out. When you run this XCTest, and suppose for some reason, if it fails, the compiler will show this error. XC as a true failed. What do we get from this? This may look like a simple test, but you have a logic sum test, but it won't be of much use, right? So when I run the new test framework test, and if it fails, you will get a message from the compiler with some more information now. And if you click on the error icon, you will have a show button, and if you tap on that, thanks to macros, you get a clear, more detailed info on what was expected and what was failed. This is so much clean, right? We know now what express macro does, at least in the introduction level. But the expect macro keeps your test running even if it fails. You may have a scenario to stop the test when something, the code doesn't satisfy a requirement. At that time, you need to consider using this require macro. The require macro serves as a direct replacement for XCT unwrap if you used in the XCTest when you are working with the optionals. Here, the require macro, when you pass an optional to it, it unwraps and returns the value if it is there. Otherwise, it throws nil and stops the execution at that place itself, so that the test will be marked as failed. So here in this example, you can see how I am using the require macro to unwrap the optional value of a user in line number 3. If I get the user only, I am intended to proceed to the next lines of the test. So if it fails, it will mark the test failure at that place itself. So you actually know which requirement wasn't satisfied. The major 4 building blocks of Swift testing are test function, which we seen, expectations, the expect macro, which we covered too. Now let's move to the next one, traits. Does anyone know what is the meaning of word trait? Trait means some character or quality. So I see this like adding a metadata or the roles you want to add to your test, like your test can perform these kind of things. Traits are useful in many ways. First is this disabled one. If you want to disable a test, like you do not want to run them for some reason, you can add this trait. The test will be skipped, and you can see in the test navigator, the test name will be grayed out, and you can see the test icon will turn out to the right one, which we seen in the first slides. Same way, you only enable the test, like run them when a condition is met. For example, here, this test will only run if it is a physical device. So I can able to check if the user has given the camera permission or not. In those scenarios, you can use the enabled trait. In XCTest, we use expectations, right, for testing the timeouts, and then wait for the expectation to fulfill. Now it's much simple. Just add the time limit trait, you are done. For example, I added the time limit trait of 1 minute here, so I don't have to manually wait for anything to fulfill. So one thing you need to keep in mind is this time limit does not support high precision timeouts. It should be always in terms of minutes. You cannot add a 500 milliseconds or something. And it should be increment in the minute, 1, 2, 10, 100, whatever. Okay, what I see is the framework explicitly do not want to add support the high precision timeout so that we avoid unnecessary overhead and keeping things simple. You can define a tag using the tag attribute, and if you add an extension to the tag, you can add your own tags. Tags can be applied to individual tests using the tags trait. You can give multiple tags also to a single test like this, network performance. So these tests are now tagged under a network and performance test. You can combine tags with other traits, like I have tagged this test under flaky test, as well as I have added the time limit trait. So if you want to relate it with your project or ask me a real use case, then for example, you can categorize some group of tests for a quick verification, or if you want to categorize some regression test tied to a specific bugs, or if you want to tag tests like in the modules level also. This is the authentication test, payment test, anything like that, you can use these tags. This was not available in XCTest. And I do not want to quote or suggest something like, hey, these are the best practices for tags, because each project is different, right? You can sit with your team and understand, then you can come up with the tags, whichever works for your project. So here, if you once you start adding the tags, you can see how it is displayed in the test navigator. There is a separate section, tags. Inside that, you can see all the tags. The beauty is you can run the specific tag alone that runs the test tagged under that. As I mentioned, you can quickly check some regression or specific bug using that tag. There was no way to track or associate a bug with a test case. Now, with the help of traits, you can. You can simply use the bug trait like this. It has various constructors. Here I used this one, which accepts a URL string and an optional title. I have tagged this bug with the GitHub issue directly. You can use with the Jira. So what is the advantage we get by associating the bugs with the test directly is traceability. You know what is the relation between a test case and a bug. Here, if you see, it's a payment bug. So I directly added the GitHub issue and a comment. And you can add documentation of fixed issues. So if some of your teammates go and check a test case, they will know clearly why this specific test was created. And some teams also automate the release notes, so it will help there also. You can automate the release notes for the bug fixes. We have seen some of the default traits which are available in the framework so far. You may have a question now, can I create my own trait? Is it possible? Yes. I have created a custom trait called offline, where I added implementation to return the network status as offline, so that the entire test can use it. Other than the network offline stub we just saw, I would categorize some common use case of custom traits so you can create and use in your projects. The first one is device-specific test, like run test on iPhone only or iPad only, so you can skip the unsupported devices. Next is environment-specific test. Sometimes you want to run this test only in a production version in the CI or only in the dev environment. You can create a custom trait for it. And the authentication-based test, this might be a common scenario for most of the projects. Like instead of setting up the login, logout logics every time in a test, you can create a simple trait and you can use the signed-in status everywhere. Database connections, resource cleanups. We can ensure to clean up the resources when test finish. With this custom trait, you can share setup code and apply the same setup across multiple tests. When you have a known issue with a test on some scenarios, now you don't have to comment the test or remove them. You can use this function from the framework. For example, the test is first checking if you are running on an iPhone, because this scenario works well in iPad. It has the issue only with iPhone. Now this function will tell the test runner, hey, this is expected to fail in iPhone, so don't throw it as a test failure. It will also make a grade icon like this in the test, which we've seen before. So if it is running on iPad, everything will run as usual. If it fails on iPad, the test will be marked as failure. This pattern, you can use it if you are testing for any specific OS version also. If you have a specific issue with the iOS 16, you can use this with known issue, so that in the other versions, the test will run smooth. One of the reasons I was in need to use third-party framework in XCTest was this. Check this code. I need to test something with various inputs. Here, I'm having an email validator logic, and I'm testing with the different inputs of emails. So it was very hard, right? Here, I need to write the test cases separately, or I need to create a for loop and give all the inputs. So these were the options. The problem is, if it fails on any scenario, you cannot see which input failed. You will just get this error like you expected was true, it was false. This seems to be a real pain. SwiftTesting now comes with the support for parameterization testing. That means you can pass argument to the test function now, and each argument will be considered as a distinct and as a separate test case also. Now you don't have to create separate test for them or use any for loop. When something fails, you will exactly know which particular input is failed, like this. It's so much easy, right? You can use maximum of 2 collections, and you can zip those collections also. So you will test each and every combination between those 2 collections. This is the last building block of the framework. You already know you can wrap tests together under one type, and that is called a suit. You can add proper name to the suits for easy management like this. You can add traits also. Instead of adding them on individual test, you can add in the suit level. So if you add a trait to the suit, all the tests inside it will inherit it easily. So I added the display name for the suit. So how you it's now changed to user authentication test. If you have a test like this, where you need to test the database operations, it's very tough with parallelization, because parallelization is enabled by default in SwiftTesting. So the first test case is beginning a transaction of adding a user to the DB. And second test is updating the added user. So if you run them parallelly, second test may run before the first one and return as a failed one. Same might happen with the remaining test cases, because the database will be empty until the first one runs and add an entry into the database. For these kind of scenarios, you have a serialized trait. When tests share resources like database connections or file system or global state, you can use this one. This ensures one test run at a time, preventing race conditions and intermittent failures. There was nothing like this in the XCTest before. Either you need to run all the tests serially or parallelly. You was not having an option to do something hybrid. Now the testing frameworks makes it flexible. So you don't have to give up your test running speed. So whatever test case that needs serially, those alone you can wrap using this trait. So you don't compromise on the entire test speed. To use the serialized trait, you need to keep two things in mind. Either you need to have some test with parameter, then only it makes sense, right? If you just have a single test like this, so a serialized parameter doesn't take any effort. So you will get a warning from the compiler like this. Either you need to use in a suit level with multiple test cases or a test with parameters. We saw we can add a tag for the test, right? You can add them at a suit level also. You can check here. These two tests will inherit the integration tag now. And if you want to give a custom or additional tag to a particular test, you can add here. Now this test will have the security as well as the integration. Okay, now it's the major advantage part. SwiftTesting major advantage is it's a framework for advanced Swift features like Swift concurrency. In XCTest, we need to use expectations and then wait for the expectations to fulfill, something like this. Which is a kind of indirect implementation, right, with a lot of boilerplate, and the code is also not easy to understand. With the testing framework, you do not need to use these expectations anymore. To wrap a closure into asynchronous context, we use the continuation API. Same here, I'm using the checked continuation API and getting my results, and then with the help of expect macro, I'm doing the assertion. So the test is clean and easy to understand. If you want to listen for unexpected failure, you can use the issue function also. With the help of expect macro, it's more easier to test some concurrency situations like this. If you check here in this example, when I pass a negative integer, I am expecting an error to be thrown. This is a negative scenario test I'm doing here. But if this is a XCTest, which is in the left side, this requires manual do catch blocks, or you need to explicitly handle the error. And as usual, you need to wait for the expectations to be fulfilled. But SwiftTesting uses a specialized expect macro, which it throws, and that elegantly tests whatever is your expected error type. In XCTest, it was around 12 lines of code, but in the testing framework, within 3 lines, you can achieve what you were trying before, and that is also very easy to understand. You can use the same continuation API if you want to test combined publishers also. Here I wrapped the entire event stream with the same with checked continuation and added a await, because since my test function is asynchronous now, here you don't need any manual expectations. Whenever the value in the event stream, in the combined stream it receives, then you can use the expect macro to assert them. So let us try this example, because whenever we see it is very shiny to see, but without seeing them in live, it won't be giving us much fulfill. So we will see a few examples which we've seen in a demo and how to test some asynchronous code. Also, if you want to migrate some of your test cases to the new framework, let's see how it's doing. Okay, hope the code size is visible. So yeah, thank you. I have an email validator. So what it does is, it just gets an email, which is a string. So it checks 3 scenarios. If it contains @ symbol, and then if there is some text before @, and it should have a domain like .com or .org. That's it, this function is testing. So if I want to check this logic works perfectly, I created the XCTest here, email validator XCTest. So I need to use the separate test cases and give different scenarios like this. This is a good email. So, and then if I have an improper email to check if the validator fails, I need to use different test cases separately. Or I need to use a for loop and give those inputs as a. So now, let me show you. If I mark this as fail, for example, voluntarily, and making the test to fail, so this will return XC asset failed, true is not equal to false. You don't know which particular test case failed, no information here also. That is the real problem which I was showing in the slides. So if you want to create a, so I'm going to use email validator test. Now we are going to use the test macro with arguments. I do not need any traits. So this is a collection. We can pass whatever I was using here before. And then I can write a function. So now there is no need to use the test keyword. So I'm going to use check email validator works correctly. So this will accept the arguments. Email is a string, and then is valid is a bool. So I'm going to use the expect macro. That's it. I'm going to pass whatever email I receive and this valid. Okay, so let me try to run this one. If you see all these use cases, so, yeah. So now I explicitly made it to false. If you tap on the error message, you get the show button. If you click on the show, you will exactly know what is the argument. The user example is valid was false, but the logic shows this is a valid email. If you see the test navigator, all these inputs turned out to a separate use case. This is the major advantage. So let me mark this as true, and then I can run this case alone. Yeah, test succeed. Okay, let me have one more example here for the asynchronous test. Here I just created a API fetcher handler service. It's fetching a data, and then if it is success, I'm just marking it to return a success result type, and then data fetch successfully. If it is a failure, I'm returning a failure with error. This is just for the testing purpose. I created a XCTest case here. So it is using the same service which I created. I'm using expectation and then fulfilling it when the fetch data is there. And I'm waiting for the expectations to fulfill, which is doing it here, and then asserting if the fetch data is successfully or not. So if you want to check how it looks on the newer testing framework, I'm going to create the completion handler test. So let me create the function itself so it will be easy to understand. Just need to add the test macro. I don't need any traits. Now you don't need to use the test keyword. Fetching data is successful. That's it. You don't need the expectation, but you need the service. Let me copy the service from here. So here I'm going to use a continuation, checked continuation API, which we seen in the slides. For that, I'm going to make this test function as a asynchronous one. Adding async here and then awaiting. With checked continuation. So I'm going to use the service.fetch data. So I'm going to use the resume, whatever the result, that's it. So I can delete this now, and the expectations, all these methods, just going to use the expect macro. Okay, there is one more bracket here. So whatever I was testing here, fetch data should be equal to this one. That's what we are asserting. Let me show the difference bit. So here, I have, with the help of checked continuation, I'm not manually waiting. I'm not creating any expectations, any timeout. The code is so linear. Let me run the test and then explain the. So I have the result. When the continuation helps me to get the result, here it's await, so it suspends the line. The code happens linear. Once I got the results, I am assigning it to the fetch data and then ascending. If you see here, it's tough to understand what it is. It may be a small test, but if you have a very big, some logics, it's tough to understand. With the help of the latest testing framework, so we can see how easy it's to write the test cases. Okay, so let's back to the slide. This demo showed us advantage of SwiftTesting, how it's naturally integrate with the modern concurrency model and making the test more swifty. So no jumping or branching, the code is linear, and it removed the manual expectations, keeping it simple. And you also saw how the continuation API naturally waits until the callback occurs. So no intermittent timeout issues. And all these things makes the code easily readable. So I don't know how many of you used the test plans before. Even I didn't had a chance to use it. But when I started using the latest testing framework, I understand what is the advantage of test plan. So I just want to give a quick walkthrough on it. I would recommend please checking that also after the talk. So this is how you can create one or modify the already created plans in the Xcode scheme. If you go to the scheme management, you can get this window. So the major advantage is now you know how to create tags. You can use the tags in the test plan, and you can create different configurations and different plans. One real-time advantage is if you have localization support in your app and if you are testing, you can configure them in the test plan. For example, you can run all tests in Italian language first, then you can run them in English separately, or if you want few tests to be in Italian, few tests should be in English. Like that, if you have a geolocation access, you can give the configuration like run this test in Indian location, run this test in Italy. So all these configurations you don't have to manually do now. You can use the test plan and just tags. Those will help you. Yeah, this is how you configure the localization, everything. You can also configure how you want the test results to be shown, what are the diagnostic tools you need to use, everything in the test plans. SwiftTesting is part of the SwiftLang open source repository now. You can view the proposals. If you want, you can add your feedbacks, or you can log issues if you have something. The community is quite active in the forums, so please do participate, if anything. Testing framework supports SPM, so if you have separate packages, you can use the SwiftTesting in the SPM also. As I told, it is integrated by default in Xcode 16. So when you create a new project, you can see SwiftTesting will be selected as a default one. And it supports the Swift language, okay, as a whole. So if you're the one using VS Code with the Swift extension, you will get SwiftTesting there also. So now the major question is, takeaway is when to use what. So if you are doing UI or performance tests, you need to use XCTest only. And if you are the one who needs the maturity and tooling support of XCTest, okay, which is not available in the testing framework, you need to use XCTest only. And if you are working on the older Swift versions or Objective-C code bases, you need to use XCTest. Okay, when to use Swift testing? If you are creating new projects, please consider. Or when adding new tests in existing projects, okay, the misunderstanding is you don't need to create any new test scheme or module. You can literally add your new test in the same file. In the demo I just showed, I have the same file. I had the XCTest. Below that, I added the testing framework. So whenever you are adding new tests, please consider using them in the Swift testing. So you can take the advantage of improved syntax. And then the only place which I recommend you to migrate the older test into the new framework is parameterization test. If you had something like duplicate test, a lot of tests with doing the same thing, consider them to moving them to parameterization, so the test will be easy to read and manage. So the takeaway, sir, please note down, it's not a complete replacement for XCTest. Hold on, at least not yet. So it's you have to still use them for whatever the performance or the UI wants. You don't need to name your test to start with the test keyword. Tests are parallel by default, so please keep in mind you need to use the serialized trait if you want to run them one by one. And one important thing which Apple says is do not mix XC assertions with the testing macros. Are the same, testing macros with XC assertions. It works actually, but it's not what it has to be. I know new framework like this takes time to understand. So I have written the complete walkthrough of Swift testing in my website. You can scan this QR. It includes all the things we discussed so far and some more extra informations. You also have a comments option at the bottom of the article if you want to have any discussion, or if you want to raise something, you can raise it there. Thank you so much.
Thank you, Muralid. Was really, you hear me? Yeah, really great. We have a bunch of questions here. I will keep them short and try to read them all. So